first flight of the prototype Boxer land and development aircraft introduced into the single-engined utility aircraft category new dimensions of versatility, safety and simplicity, designed to meet worldwide demands that so far have not been met by the world's aircraft manufacturers. From various configurations investigated, the tandem wing layout was chosen because it can combine efficiency and simplicity with safe flying characteristics. Following wind tunnel investigation, a 7/10 sized proof-of-concept aircraft was built, flown, and upon which all the development work to date has been carried out. The aircraft is shown in this video during various stages of development. The all-up weight of the Boxer is in the order of 4,000 pounds, depending upon the version and choice of engine, and has an average disposable load of 1 ton. The initial design was based on a Lycoming 290 horsepower engine. However, any engine, either piston or turbine, up to 450 horsepower could be fitted. Greater safety is achieved by combining exceptional visibility from the cockpit with a low noise and vibration level, an advantage of the rear-mounted engine. This results in a cockpit having a lower fatigue level and in particular benefit when low flying. For the initial program, the aircraft was fitted with an 85 horsepower Continental engine and had a four-wheeled undercarriage having Ackermann steering that enabled it to taxi with precision over the removable centre fuselage pannier. This may be of a variety of types, carrying cargo, stress air relief, supply dropping, firefighting and many other roles. This four-leg undercarriage arrangement is also used to enable floats to be fitted. As the foreplane is designed to stall before the main plane, and the latter carries the primary roll and pitch controls, the aircraft has exceptionally good low-speed handling and ultra-safe stalling characteristics. Wind tunnel tests were used to develop this, and flight trials confirmed the docile behaviour. With the stick held fully aft, the nose gave a gentle nibble as the foreplane stalled and unstalled, descending power off and climbing with power applied. There is no danger entering the cockpit or loading and unloading passengers or cargo while the engine is kept running, as these activities take place well forward, separated and protected by the wings from the propeller. Simplicity has been the guide in this design to ease manufacture and assembly. Built from light alloy and steel tube, the prototype was designed structurally as well as aerodynamically to be a proof-of-concept research aircraft. The three-section fuselage, front, centre and rear, enables ease of servicing and fitting replacement sections, either for repair or changing roles. The wing panels, control surfaces, fins and rudders are made from light alloy in the conventional manner with ribs, spar and stress skin, typical of the type with which general aviation aircraft maintenance facilities around the world are familiar. This enables small repairs to be carried out in the field by crew members with a repair kit of light alloy sheet and hand tools. The Boxer has a higher commonality of components than any other aircraft. All three wing panels of constant cordon section are identical, as are the 6 associated control surfaces, and both fins and rudders are identical. The simplicity of structure, combined with an unprecedented degree of component interchangeability, means a substantial reduction in tooling and production costs, which in turn results in a significant cost saving to the operator in his reduced spares holding inventory. Versatility is achieved by having unrestricted positioning of the load up to 1 ton, 1,000 kilograms, either in the pannier or the 250 cubic foot, 7 cubic meter, box-shaped cargo area. The doors enable a truck to back up, load and unload directly into the fuselage, as access is unobstructed and unhindered by wing lift struts, tapering fuselages or sloping floor lines. The centre of gravity range, around 4 times that of a conventional aircraft, means that in practical terms, that if the aircraft is standing on its wheels, it is safe to fly. A Boxer can carry all its own spare parts, all being stowed internally, except for the wing panels, which are carried externally on the underside of the fuselage. So for even the smallest fleet operator, complete independence from other types of aircraft or service vehicles is achieved. For long-term storage or shipping, all 3 wing panels may be attached externally on a fuselage luggage rack, the remainder of the components being housed internally. The aircraft may be taxied in this state. The major amongst many changes made at the first development stage included replacing the engine with one of 160 horsepower, fitting a tricycle undercarriage and the side-loading doors. The final stage of development, bringing the aircraft to the anticipated production configuration, was directed towards improving performance and handling by fitting new wingtip-mounted fins and rudders, simplifying the control system, increasing the area of the 4-plane wingtips, and reducing drag, most notably of the cockpit. The 3-section fuselage means that to suit a particular role or application for which the aircraft is to be used, variations only of the appropriate part of the structure need be changed. For example, different cockpit configurations, or fuselage center sections, the side-loading door version for passengers and cargo, the removable pannier which, with rear hinge, allows the forward end to be lowered, forming a scoop to take aboard liquids such as water for firefighting. The drawings show the standard airframe, also fitted with floats, and a fuselage center section specially designed for tourism, photographic survey, and movie making. The development potential of the basic airframe is very great, both in respect of enhancing the performance through changes in engine and propeller, the fitting of high lift devices, and in the many roles it could fulfill, equipped for operations from land, sea, or snow. The aerodynamic configuration, performance, and handling characteristics have been defined on a sound basis of calculation, wind tunnel investigation, and flight test, researched to a much greater depth than is customary for this category of aircraft. Simple, safe, and inexpensive, it is a uniquely versatile utility, having enormous development potential to meet the worldwide range of applications, and will remain so well into the 21st century.